All right, so you're diving in, building this amazing new generative AI app on AWS, and it's super exciting. But there's this one huge trap, a mistake that I see people make over and over again that can turn your awesome prototype into a total production nightmare. We need to talk about it.
Yeah, this thing, the giant monolith function. It's so tempting, right? To just cram everything, fetching data, calling the model, processing the results, updating a database, and shove it all into one giant Lambda function. Seems easy at the start, but trust me, it's a one-way ticket to a world of pain. Timeouts, failures, you name it. So, how do we dodge this bullet? Well, it all starts with one single fundamental choice.
And that big choice, it really just boils down to this. Are you going synchronous or asynchronous? And look, this isn't just some nerdy technical detail. This is the fork in the road. It's what decides if your app is going to be tough and scalable or fragile and just waiting to fall over.
So what's the real difference here? Honestly, the mental model is super simple. Think of synchronous like this. A human is waiting, period. They've clicked a button, they've asked a question, and now they're just staring at that little spinning icon, waiting for an answer right now. Asynchronous? That's for all the stuff that can finish later. The user has already moved on. They're doing something else, and the system can just chip away at the work in the background. No pressure.
So you're definitely going to go synchronous for things like a turn in a chat conversation, right? Or maybe a quick lookup, like checking if a product is in stock. The name of the game here is speed. Low latency is everything. You've got to be fast, you've got to be predictable, because there is a real person on the other end of that connection. Now on the flip side, for those bigger jobs, like say ingesting a whole bunch of documents, or running OCR, or generating a summary after a phone call has already ended, you go async. Every time. And here what we care about is totally different. We're not worried about a few milliseconds. We're focused on building a system that's tough. We want it to be decoupled, so one part failing doesn't bring everything down. We want it to be retriable, and, this is key, idempotent, which is just a fancy way of saying you can run the same job twice and not mess things up.
Okay, so to actually build these patterns, you need the right tools for the job. Let's open up our AWS integration toolbox and look at the key players. And I've got some simple analogies to help make these stick in your brain. First up, API Gateway. I want you to think of this as the toll gate for your application. It's literally the front door. It's checking IDs, that's authentication. It's managing traffic flow, that's throttling. And it's directing cars to the right parking spot, that's routing the request to the correct back-end service. It's your bouncer and your traffic cop all in one.
Next in our toolbox is SQS. Think of this as the waiting lane on the highway. This is your shock absorber. When you get a sudden flood of traffic, or maybe a service downstream is running a little slow, SQS just holds onto those requests in a nice, orderly queue. It prevents your system from getting totally swamped. This is absolutely critical for decoupling services and handling failures and retries without losing data.
Then we have Event Bridge. The best analogy for this is a traffic roundabout. So an event happens, like, hey, a new file just got uploaded to S3, and Event Bridge sees that event. It then looks at its rules and routes that message to all the different roads or services that need to know about it. It lets you fan out that news without any of the services needing to be coupled together. It's a beautiful thing.
Okay, so here's a really important distinction. SQS versus Event Bridge. How do you decide? It's actually super simple when you boil it down. SQS is for commands. It's you telling the system, do this specific job. Event Bridge is for events or notifications. It's the system announcing, hey everyone, this thing just happened. One is a direct order, the other is a public service announcement.
And last, but definitely not least in our core toolbox, we've got step functions. This is your choreographer. Anytime you have a process that's more than just one step, like first you extract the text, then you chunk it up, then you create embeddings, then you store it. Step functions is your hero. It orchestrates that entire dance, managing the state, handling errors, and coordinating retries automatically. You just define the steps, and it makes sure the dance happens correctly.
All right, we've got our tools. The toll gate, the waiting lane, the roundabout, and the choreographer. Now let's see how they work together. We're going to look at two super common GenAI blueprints that you'll be able to sketch on a napkin after this.
First up, blueprint number 1, the synchronous chat request. This is that classic human is waiting pattern we talked about. Super common.
So check out the flow here. It's pretty straightforward. The user's message comes in through our tollgate API gateway and hits a Lambda orchestrator. This Lambda's job is to be quick. It grabs some context, maybe does a RAG retrieval from a vector store, calls the Bedrock model, and immediately starts streaming that response back to the user.
But, and this is a clever bit, look at step 6. After its main job is done, it quietly fires off a chat-turn-completed event to our roundabout event bridge. This is brilliant because it decouples all the after-the-fact stuff, like logging or analytics, from the user's critical path. The user gets their answer fast, and the other work happens in the background.
Okay, now for blueprint number 2. We're going to flip the script completely with an asynchronous document ingestion pipeline. This is the perfect example of work that can finish later. So here's how it works. A document gets dropped into an S3 bucket. That simple action kicks off our choreographer, a step functions workflow. From there, the user is out of the picture. Step functions takes over completely, managing that whole pipeline we talked about. Extract the text, chunk it up, create the embeddings, and finally, update the search index. The person who uploaded that file could be on vacation by the time it finishes, and it doesn't matter. The system just chugs along reliably in the background. See? Once you understand these two fundamental patterns, it brings us right back to the beginning. It gives us the golden rule for avoiding that nasty monolith trap we started with.
So let's just get really clear on why that giant Lambda is such a bad idea. First off, there's no isolation. If the part that caused the database fails, the whole thing crashes, even if the AI part worked fine. Retries are a nightmare. You retry the whole function, you might end up sending the same email twice or charging a credit card again. Not good. You can't scale efficiently. Maybe you only need more power for the embedding step, but you have to scale the whole monster function. And of course, you're always racing against that 15-minute timeout clock. It is just a mess to debug and maintain in production.
Look, if you walk away with only one sentence from this whole thing, I want it to be this one. This is the exam question. This is the thing to write on a sticky note and put on your monitor. Decouple any long-running or failure-prone steps with SQS and a dead letter queue, and orchestrate any multi-step flow with step functions. That's it. That's the secret sauce. Okay, so following that golden rule, that gets you like 90% of the way to a solid, resilient architecture. But if you want to go from good to truly production grade, there's a final checklist we need to go through.
This is your production readiness checklist. First, idempotency. Just assume retries are going to happen and design your functions so that running them multiple times doesn't cause problems. Second, smart retries. Don't just hammer a failing service. Use exponential backoff and jitter. Third, DLQs and a replay strategy. You need a plan for what to do with messages that just keep failing. Don't just let them disappear. And of course, the non-negotiables. Security with least privilege access and observability. You have to be able to see what's going on, track latency, errors, and how deep your queues are.
So let's just run through our handy analogies one last time to lock them in. API Gateway is the toll gate, your front door. SQS is the waiting lane, your buffer. Event Bridge is the roundabout, your event router. And Step Functions is the choreographer, your workflow orchestrator.
In all of this, all these tools and patterns, they bring us to one final really important question you should be asking yourself. By moving past that simple, tempting monolith and embracing these decoupled, event-driven designs, you're not just building an app that works right now. You're building something that's truly resilient, that can scale, and that's ready for whatever the future throws at it. So, is your architecture built to last?